All right. Okay, so the first thing is annotate things. How many of you guys trying to graph this function and come up nothing?
Not me.
You graph it? Okay, try to graph it first, and then see what happened. And you're gonna see something that's
It goes up and then comes back.
okay. Or did anybody see just a straight line?
Yeah, but then you like
It's both.
Okay. So the thing is about it. This is I'm gonna kind of explain to you what the situation is. I don't know if you guys ever go to New York to ride a subway. So if you get off like say main central station and there's escalator that's going up, right? So when people get off the train, so kind of like similar to that situation. So what happened is you probably have some type of train that just arrived, a subway just arrived. Let's say this is a train. Um, oh, it's a grand opening. They didn't say anything. Okay, so there's some type of train that's coming. Um, so let's just say there's an escalator here. As you know, just keep on going upwards. Um, and so before the train come in, that but after the train left, about 300 seconds, about what? That's about 5 minutes, right? So after 5 minutes, probably nobody going at first. It's gonna be a lot of people get out of the train and then go into the escalator. But after 5 minutes, probably nobody go in the escalator anymore. Only people are slowly leaving the escalator. And it's probably the same situation here. So what happened is after 300, then there was actually nobody entering the escalator. But there was still people leaving at 0.7 person per second. And that's a situation that you had to see. Now, you have to say, well, let's annotate all the stuff. So I would say this is super important. When you graph it, make sure you graph between 0 to 300. Most of you graph negative 10 to 10. You normal zoom window is not able to see that whole graph. So for me, I will even use the x min to be as low as that says negative 20, and x max is going to be that's equal to 320. Why is that? It's going to be, I have some slack room to cut to see like what happened a little bit before that and a little bit after that. It doesn't matter. You can do 310 or you can even do 30 to 300. But for me, the habit to see the whole spectrum of the graph, especially I like to see on the left side of the axis. Although it doesn't make sense to see negative time, but I just want to see where the graph comes from. So with that being said, this is the things I'll annotate. This is a net rate. This is the initial condition. This is actually this is the out rate. Sorry, this is the out, and this is the in. So net is equal to in minus out. That's always true. Okay, so the net is in minus out. That's just the way I kind of think about it. So for the first part, first three part is really fast. A is going to be integration between 0 to 300 of RT dt. So first thing first, you cannot just write down 270 and expect to get credit. You have to write down this and then equal to 270 and expect to get credit. Second, some student asked me, do I have to write this whole thing out? No, if they give you a functions RT, use just the integration RT. You can type it in there. Another thing is I will never graph integral. Some people try to graph integral for part D. That just doesn't work. Don't graph integral. Because you're going to go to infinite spin, and that's bad. So at first, during the time 0 to 300, so during time interval, there are always people in line escalate. How many people are in the line at 300? Now, as opposed to the first question, they say how many people enter in the line. So that's one doesn't need to include an initial condition because they just want to see how many people enter the line. They don't care about those 20 people beforehand. That doesn't make any changes. So what happened is you're going to say, okay, between that, so it's going to start with there was 20 because there was 20 people to begin with. and then plus the net rate. Well, think about it. Net rate is a velocity. If you integrate the rate, I'm gonna say integrate velocity is gonna be among the distance I travel. So if I integrate the net rate here, I'm gonna find out how many people I gain or lost throughout the whole time. So this is gonna be 0 to 300, and that's gonna be R of t. And some people did this a little bit different. I did it this way. I did minus 0.7 dt. Now some people do it this way. It's 20 plus 0 to 300 R of t dt, and then plus, now this is end of the integral, plus 0.7 times 300, minus, sorry, minus that, but it's after the integral they did that. So that's, some people did that. I should prefer the first way better. I prefer this way better because this one's gonna give me 80. So 80 people. Write down the units. 80 what? 80 people, 80 fishes. So those are things that you should pay attention to. C. Now, they say t is greater than 300. So some of you guys got 114. It's already started bad. But you had the right idea, right? So it's going to be 300 plus, well, I ended at 300 second. I have 80 people left. So it's going to be 80 and divided by 0.7. And I'm going to say this is the people, and this is the people per second. And so that's going to cancel out to be second. So it'll be 414 second, 0.268, I think. And that's how you had to write. And that's how you get all the points. Now part D. D is kind of hard to understand. Now, I'm going to give you two analogy. If I throw the marker up, right, I'm going to have some type of positive velocity, right? If I throw it up, guess what? I have some type of positive velocity when I lift my hand. So this is positive. But the gravity is have a negative acceleration, has the other way. So it's pulling up. So when you get to the highest moment, the velocity is equal to what? Zero. So when velocity is equal to 0, it's going to create a maximum or minimum. But I hear is the net rate is a velocity. So another thing you have to understand is the net rate is the velocity, because the velocity of people go in and out, right? Does that make sense? So what I'm going to do is I'm going to set the net rate equal to 0. Why net rate equal to 0? Well, two things can possibly. I have an escalator here. Of course, I'm going to draw in terms of how much the line is. Now, if I have a, let's say I'm going to draw it here. So I'm going to draw it here. So let's say if I have 4 units comes in, and those 2 units goes out like this, I use a grid to show you. If 4 unit comes in and 2 units gonna go out, what do you think? If this is just look at this, let's just say it's water, it's filling the water, there's more in and there's less going out. The water is going to be rising or going down? Rising. It's rising, right? But when do they stop rising? When they stop rising is what? When you have, eventually like this keep on going, this keep on getting bigger. If the going out is the same as going in, then you'll have a stop at the maximum. Same thing if it's the other way. We are looking for minimum, right? So at first, if I have this much going in and this much going out, well, the certain amount is going to go down first until the in and out reach becomes equal to each other. That's when they stop, because they stop and then they start moving back up. Does that make sense? Yeah. So you really need to look for that net rate equal to 0. Well, what's net rate? Which is R of t minus 0.7. And you're going to graph this. And how do I graph this? So I'm going to show you on here. So I'm going to go to the graph. And I'm going to go to tab. I'm gonna go to graph this one here. So once I graph this, I don't know why this graph is this way. I'm just gonna get rid of that. I'm gonna do new graph. Sorry. New. No. So I'm gonna do new graph. Wait, how come I not get rid of this? New. Adding graph. There we go. So I'm gonna type in this function in. So when I type in this function in, it's gonna be RT. So be 44 parenthesis x minus x divided by 300, I think. Is that right?
Yeah.
It's 100. So I'm gonna do D, and that's gonna be 1. And I'm gonna go to all the way here times by what?
1
X over 300 to the 7th power. Okay, so I'm gonna press enter here, and I'm gonna graph. See that straight line? That's a problem. And I'm gonna go to menu, window setting, and I say 9 to 10 is fine. I can go to 300 here, maybe 320, and I can graph, and I see this graph, right? Now, what happened is that's just RT. I want a minus 0.7. If I go to the tab here, and then we'll go to the next function, I can click on the var, and function click enter, and the X. So for you guys, for TI-84, you can do minus Y1. So same thing here is going to be minus. Minus what? Minus F1. So minus F1, press enter of X. Oh, crap. There's extra in X. Right, and I'm going to press enter here. So now you see this graph. Wait, what happened? So I'm going to go to tab. And then we'll go up. Oh, minus X, right? Minus, wait, so is this part minus 0.7, sorry. Delete is 0.7. Okay, so now I'm gonna graph it now. Press enter. And then I see this. Do you see that? I can go to tab here. I can say I'm not gonna graph the first one because that's kind of confusing. So I don't want to need to use that anymore. I just use this graph, the bottom here. Now I see this is there is more going out. Do you see that this part is more going out because native area, and there's more come in. So probably at first, like the trains haven't arrived yet. Whatever in the escalator is still leaving. Okay. Now when the train arrived at this moment, about 33 seconds. And then the big rush of people start coming in. And then there's more people leaving after that. So probably this going to be happen. So minimum occur definitely went from negative to positive. So then you kind of have to say menu, and you're going to have to analyze the graph, analyze the zeros, going from here to here, and then you're going to get 33. You can even analyze the other one. Doesn't take a long time. So it's going to be 0. But this one's going to be maximum, by the way. So this one's 167. So how do I find out how many people were there? Well, I find out how many people are there. I'm just going to go back to the calculator screen. I'm going to say, I don't know how to do calculator screen. How do I do calculator screen? Oh, there we go. So I can do this. See this? At 33 seconds, I have 20 plus 0 to 33 of the net. So it'd be 3.803, or 20 plus 0 to 164 is in 158. So those are the things that's important here. So I went ahead and I do 20 because I find out this equal to 0 when t is equal to 33 and t is equal to what? 167. Now the justification is like this: t 300. I mean not 300, but t and the people. Now you had to do a table, which is 0 to 300. So 0 is 20, 300 is 80. And then you say, okay, well, let's figure out 33 is. 33 is roughly to be 4 because it's rounded to nearest number. So it'll be 4 people, not 3, because I said nearest. And then go to 150, 167. It's gonna be 158. So for at 33 second, there is 4 people in the line, which is the minimum, absolute minimum. It's the absolute minimum. Does that make sense how I developed going from the beginning to the end? Now, really important part, set the net rate equal to 0. That's going to create a maximum or minimum. Once you create a relative maximum minimum, guess what? You have to do a table to justification. Number line is not justification by all means. Second thing, please don't graph integral. You're going to get an infinite spinning wheel. Your calculator gets stuck there and you don't know how to reset it. Even though there's a button in the back, you can reset it. But still, you don't want to do that because probably you're going to believe that's like a curse. The calculator is racist or something. I don't know. So it doesn't like you. Okay, so the work is not a lot. Do you see the work is a lot? No. But you got to write that out. You cannot write down 270. You have to write down integral between the 270 or integral from 0 to 300. So people like Andrew, people like, I don't know, Jordan doesn't write out too much things. Make sure you write this out. This is the minimum of stuff you have to write out.
Yeah, sorry.
You cannot write down 270 like that. It's not going to cut it. I'm good with the answer, but you got to show them the work. Okay, so we're going to talk about the second question. Now, second question, that there is a problem. We deal a lot of problem before, but we only deal with one particle. This is the first time for recent year, for 2018 and 2017, there's 2 particle situation. So this is one particle, but it's not that bad. Now, I do want to ask you, if I were a test creator, I will also ask following sequence of the questions. For example, E. What do you think velocity they usually ask? Well, they will ask you at t equal to 2, particle A is speeding up or down. Do you remember how to do that?
Yes.
Take a derivative and take another. Take a derivative, compare the velocity and acceleration. Use a table to figure out, right?
Yep.
F. I might ask you, says, well, can you find average velocity between 0 to, I don't know, 3? I will ask that. G. The harder tier question they might ask you is what? They might ask you, says, when is a particle? Well, we already did that part.
That's the easiest one.
When is a particle at furthest? Furthest left? Like the furthest left or furthest right? Between 0 to 4. Okay, so you had to do a table for furthest left. You had to do a table for furthest right. Those are the things, there's only a small difference between first left and first right. It's just looking for the maximum, absolute maximum, or absolute minimum. So those are part of the extension that they might ask you. They might ask you average acceleration as well. But average acceleration is pretty easy. FGH, they say average acceleration. Average rate of change in velocity, yes. So let's just say between 0 to 4, something like that. They can ask you as many extension as possible. So when you study one question, don't just study on the 4 parts. Ask what if they ask if it's slowing down or speeding up. Ask if you know how to average velocity. That's average value of velocity actually. But how do you define furthest left and furthest right? How do you find the average acceleration? Those are the following questions, the extension that they might ask you. You had to take account into both because sometimes they don't ask you to find acceleration. Sometimes they're more likely to ask you speeding up or slowing down at t equal to thing. Initial conditions, worry about those. Equations, domain again. Do you see that domain? If you do 0 to 10 graph, that's a very ugly graph. But if you do 0 to 3.5, that's a very nice looking graph. So those are the things that you gotta be able to do. Now, what time we get off here? 1:24. I'm just gonna go straight. Is that okay? Okay. So what I'm gonna do is I'm gonna go to menu. I'm gonna go to adding a graph, and I'm do oh, I already have this. So this is the graph, and I'm gonna do between. I'm gonna highlight this one. I'm just gonna graph this particular one here. So we see at 2.8, 1.4. So we can see a lot of things. So find the acceleration at t equal to 3. Well, this is a velocity graph, right? How do I find the acceleration? Take a derivative. So this one is F3. So what I'm going to do is I'm going to go to tab. I'm going to take a derivative, which is shift. I think shift minus or control minus. Is it shift minus? Okay, shift minus. This one doesn't take the thing, so I'm gonna get rid of that. I don't do one shift minus. I'm gonna do menu. Oh no, we're gonna do this button here. Where's the derivative button? I'm blind.
It's gonna be exactly the same. The same thing is just the right opposite. Yeah, it's gonna be the same as shift minus.
But do they have a x equal to? Like,
Yes, they do. You go to menu.
is it the menu?
Yeah, first menu, and calculus.
Calculus?
And derivative at a point.
Derivative at a point. There we go. X equal to 3, right? And the derivative, the first derivative, okay. Oh, there we go. And I'm gonna do F3. So F3, thank you, Asim. That's really awesome. I don't know how to use this. But in your TI-83, it's the same thing. There's a button says derivative, and you can plug in x equal to something. So I'm gonna press enter. That should give you negative. So D. Do you guys did it? Okay, D to the D T when T is equal to 3 of V of T. So D to the dt of V of T. Plug in T equal to 3. So I got negative 2.1182. Now, is this speeding up or slowing down at T equal to 3? Do you remember you had a graph?
I think it's speeding up.
Yeah, so if you look at a graph, right? If you look at a graph, 3 should be right. This, well, it's 2.8 here. So it's negative here. So it's actually speeding up.
Oh, snap, I'm a genius.
So 2.8, because 2.8 is almost 3. So 2.8, so it's going to be negative here. And also negative is actually slowing down here. But I didn't ask that. Now, how do I find a position at t equal to 3?
Integral from 0 to x.
But do you,
you have specific x values, so you can just do the integral from 0 and then plug in.
what do you do including the initial condition?
We're not doing city. I'm sorry. And you subtract the big one.
So what you're gonna do is gonna go to tab here, and I'm gonna say, hey, that's integral. Let's take a integral. So shift plus, between 0 to 3. Between 0 to 3, and what else? B of t, so it'll be f3 of x close interval, and x, and don't forget about subtracting 5. Oh, or I can put in front says -5.
Would that multiply everything by 5?
No, -5 plus.
Oh. I thought he was multiplying, not adding.
Is it -1.76? Is that right? Okay, so what's difference between 0 to 35 and 0 to 35 v of t? What's the difference? This is what? Total what? And this one's total what?
Displacement and position.
Which one is the displacement?
Displacement is absolute value.
No.
No, it's the other one. Sorry. I knew that.
Total distance is this one, and total displacement is this one. So I'm gonna have to integral this. So I'm gonna do shift plus, and from 0 to 3.5, right?
Yes.
And then, oops, my bad. 0.5. And how do I do absolute value? But it's what? How do I do absolute value?
The little absolute value bars.
You can do it. Press the little button.
You know, this is the same button that you press to find the derivative. That not the shift thing, but the other one.
So this one?
That one, yeah. And then there's the absolute value.
There's an absolute value. What the hell?
There you go.
Listen, don't teach us the faster way.
Wait, how come?
Don't fix it.
Why it's not working though? Absolute value?
Give it a backspace. Yeah. No. What do you?
Click the select button on the actual calculator.
Enter on the phone. Oh, no one is being. There's literally a button right next to the button that doesn't calculate.
I don't know how to do this. Oh, there we go. Bars F3
It's actually
X. So this is the total distance. And I can go get rid of X here. So I press enter. It's 3.73. So this one's 3.737. Can you predict displacement's gonna be less or more?
more.
It's gonna be less because it's the absolute value, right? So I'm gonna have to get rid of this. So F3, so that's gonna be var F3 of X. And that's 2.84. And this 2.84, this total displacement 3.73. How do I compare they are the same velocity? Well, I can take a derivative of this, right? It's equal to 2t minus 1, right? And I can graph, I can set this minus that. So v of t minus x prime of t is equal to 0. Do you see what I'm saying?
No, I'm not.
Because the velocity, you want a velocity is same as the prime, because that's you compare to velocity. Then you can actually graph this, finding the zeros.
Oh, it's kind of like when you if I get everything right, equal to something.
Yeah, same idea.
For C, total distance and total displacement.
Huh?
For C, the explanation part, do we just put total distance?
Yep.
Oh, I finished the book. Yeah, here it comes later. It's on Joan of Arc. Joan of Arc. Joan of Arc.
Park is going on.